Dear students, in this video, we are going to discuss what happened when dielectric slab is between the parallel plates of capacitor, but battery is not connected. And the second case, when battery is connected across the parallel plates of capacitor. So in this situation, how your charge, potential, electric field, energy behave. So all these parameters we will discuss one by one in this video. So first of all, we will discuss what we have to find, what we will understand the topic concept. So let us consider I have a plate of a capacitor. So I have a parallel plate capacitor. One side is positive and the other side is negative. In this side positive Q charge and this side negative Q charge is generated on the plate of capacitor. So what will happen if we connect this capacitor with battery, and battery is in the on condition. So what will happen when it is on? And the second case we will discuss what will happen to the other parameters like potential, charge and all when this battery is not there. No battery means this is in the off condition, and charges after charging the capacitor, we disconnected the battery and we switch off the battery. So how in this situation the capacitance will affect, potential will affect, your Q will affect, your electric field will affect, and the last is your capacitor energy will affect. So all these things we will discuss one by one. So first of all we will discuss for on condition, then for off condition. So for on condition I will discuss, then we will compare the two conditions. Alright, so first of all for all condition, how the capacitor will behave. So firstly, when battery is connected across the plate, so how the potential will vary. When battery is connected across the plate, the potential V remain constant. Why it is constant? Because once you have supplied a potential through battery to the plates of the capacitor, it will get charged. It is fully charged. So whatever the value of capacitor potential here, if it is 5 volt potential here, so same potential the capacitor will get from the battery. So this thing will not change. So potential will remain constant in this situation. The second case, how the capacity will vary. So for capacitance variance, we already this formula and this concept, whether you have a dielectric, and in this case one thing I missed, dielectric slab is also between the two. So the case when dielectric slab is between the two plates of capacitor, always capacity increases. So directly we can write here, because we already derived how capacity increases. So from that derivation we can say when we inserted a dielectric slab between two parallel plate capacitor and battery is on, so in that case capacitance will increase. So this is the second case. And the third case, for charge, Q is equal to CV, we can write from this formula, because we know capacitance is equal to Q by V. So from this formula we can write this thing. So as we know, V is constant when battery is connected. V is constant, it is not getting changed, only constant potential we have supplied here. So same potential across the battery, across the capacitor plates. And C is going to increase. So what will happen to charge? So overall the C is going to increase, V is constant, C is going to increase, V is constant. So overall this Q will increase. So when capacitor is increasing, potential is constant, overall charge get increased. So now we will discuss about electric field variation. So how the electric field will vary. So as we discussed in the previous video, when there is a two plates of capacitor, positive and negative plates, so there is a field, electric field, external electric field we call. But when we inserted the plates of the capacitor, so due to the polarization of dielectric substance, internal field is developed, that is your EP. So now two fields are there, one is E, other one is EP. So what is the net electric field of this system? So you can see this field direction is this side, this field direction is this side. So overall the electric field will get decreased because both having the opposite direction, and we will subtract them. So overall electric field will decrease. Next is we will discuss about energy. We have a formula of capacitor energy, parallel plate capacitor energy, U is equal to half CV square. This C capacity is going to increase from the second equation, and this V is constant. So we have constant V, this term is constant and this term is going to increase. So overall the energy will increase. So we discuss 5 parameters one by one. So in the first parameter, V will remain constant. Second parameter will increase. Third parameter is charge, that will also increase. Energy will also increase. Only the parameter which will decrease is electric field. So same thing, same parameter we will discuss in case when there is no battery. Now in the second case, battery is not present. Once we charge the capacitor, the battery is disconnected. So now it is in the off condition. So when there is no battery, then how the charge will vary? First of all, we will discuss charge. Once you charged the capacitor plates with the battery, that it will store the maximum charge. So suppose here charge positive Q is there and negative Q charge is there. So in this condition, now these plates of the capacitor is not getting any charge and they are not doing any work. So the charge will remain constant in this case. So Q remain constant. And the second case, now we will discuss capacity. So capacity of the capacitor always increases whether it is connected or not connected. We already discussed this parameter. Capacitance of parallel plate capacitor always increases by K, because when you inserted a dielectric medium between the parallel plate capacitor, whatever the value of dielectric constant, that much time the capacity will increase. So it is increased by K factor, K times it will increase. From the dielectric constant definition we can say. And the third one, now we will discuss potential V. So as we know, V is equal to Q by C. Q is your constant parameter, C is increasing. So this parameter is going to increase. So if denominator is going to increase, so this is reciprocal. So overall potential will decrease. So when dielectric slab is inserted, overall potential will decrease of the parallel plate capacitor. Now the next is electric field variation. So we know the formula, E is equal to dV by dr, that is potential gradient formula. So from this formula we can say V is decreasing, or we can even rearrange it. From there we can get the value. dV is equal to E dr. So E is electric field and dr is distance between the two plates of the capacitor. This is your dr. So we are not changing the distance, so dr is constant. Dr is constant, and now we have to find how the E will vary. So from this formula directly we can write, because this thing is constant, only it will depend on this. So if dV is decreasing, means potential is decreasing, so overall electric field also depend on it and it will also decrease. Okay, the next is energy U. So for energy we will write the formula of the energy in terms of charge and capacitance. So again Q is constant in this case and C is increasing. So this term is in denominator is increasing, so overall energy will U will decrease. So energy will decrease in this case. So again I'm going to summarize this. When once a capacitor is charged, the charge will remain same because we have disconnected the battery here, and we know whether you inserted a dielectric medium, the capacity will increase by k times. So overall capacity will increase whether battery is connected or not. In the second case, we know that this relation V is equal to Q by C. If capacity is increased in the second case, so this is reciprocal, potential will decrease. In the next case, E is equal to dV by dr. So this thing is constant, so your electric field will depend on potential, that is your dV. So dV is decreasing, potential is decreasing in the third equation, third point, so overall electric field also decrease. And in the next case, that is U, energy. So energy is equal to Q square by 2C. So Q is constant and this C is increasing. If this denominator is increasing, so U will decrease because these are reciprocally to each other. So I hope this concept is clear to you. This is very important question from CBSE board exam point of view, and the most important question they can ask based on this topic, based on these cases. So I hope you liked this video. If you want to more video, so please subscribe my channel and don't forget to like my video. Thank you.